How do you properly route MIDI with hardware and software? Imagine you have a bunch of musical devices and software all waiting to work together smoothly. Getting them to communicate correctly is what MIDI routing is all about. It's like setting up a traffic system for musical signals to flow without jams or confusion. Whether you're working with hardware synthesizers or digital audio workstations, understanding how to route MIDI properly makes your music production flow effortlessly. First, you need to know where your MIDI signals start and where they need to go. Hardware devices usually have physical MIDI ports, which are either 5-pin DIN connectors or USB ports. Software uses virtual MIDI ports, which are like digital pipes inside your computer. Knowing which device sends MIDI data and which receives it is the first step. Next, you should understand the functions of MIDI through and MIDI merge. MIDI through takes the data coming into a device and sends it out to multiple destinations. For example, if you connect your MIDI keyboard to a MIDI interface with a through port, you can send the same signals to different synthesizers at once. MIDI merge combines signals from different sources into one stream, which is useful when you want to control a single instrument with multiple controllers or sequencers. Using virtual MIDI ports is essential when routing MIDI inside your computer. On Mac computers, you can use the ISE driver, and on Windows, Loop MIDI is popular. These create virtual pathways that let you send MIDI data between different software applications. Many digital audio workstations also have built-in routing features, allowing you to assign specific MIDI inputs and outputs to tracks or instruments. Configuring your DAW properly is key. For example, you might set a MIDI track to receive input from your MIDI keyboard and send output to a virtual instrument or hardware synth. Some DAWs like Ableton Live or Logic Pro have advanced routing options, including scripting or environment setups, to customize how MIDI flows. Managing MIDI channels and messages is also important. MIDI messages include note on and off, control changes, program changes, and clock signals. Routing correctly means filtering or remapping channels so each device only responds to the messages it should. This prevents conflicts and ensures each instrument plays the right sounds at the right time. Hardware MIDI interfaces with multiple ports are helpful for complex setups. They allow you to connect several hardware synthesizers and controllers, and some include features like MIDI merging and filtering. These devices keep your signals organized and maintain timing accuracy, especially during live performances. Finally, keeping your firmware and software updated is a good practice. Updates often improve compatibility and add features that make routing easier. For example, some hardware devices get firmware updates that enhance their MIDI handling capabilities. Picture this: you want to control two synthesizers from one MIDI keyboard. You connect the keyboard's MIDI out to a MIDI interface or a hardware router with a through port. This splits the signal so both synths receive the same data. Or, inside your computer, you set up virtual MIDI ports and route the keyboard's output to different tracks in your digital audio workstation, each controlling a separate virtual instrument. In a live setup, you might route MIDI clock signals from a drum machine to synchronize sequencers while also sending note data from your controller to multiple synths. Using both hardware and software routing tools together keeps everything in sync with low latency. To sum up, proper MIDI routing means understanding your devices, inputs and outputs, using through and merge functions wisely, leveraging virtual MIDI ports and routing software, setting up your DAW correctly, managing MIDI channels carefully, and employing hardware interfaces when needed. This organized approach ensures your MIDI signals flow smoothly, making your music production experience seamless and fun.